Okay, so section 4.5, we are going to look at solving exponential equations. So an exponential equation is just an equation in which the variable is in the exponent. And when you see the variable in the exponent, you want to follow these steps. So step 1, you want to isolate the exponential expression. Okay, the base and the exponent you want to isolate. Step 2, you want to take the logarithm of both sides and then use our laws of logarithm to bring the exponent out of, bring the variable out of the exponent. And then step 3 is to solve for the variable. Okay, so we're going to follow these 3 steps as we look at the following equation. 3 to the x plus 2 equals 7. So you know this is an exponential equation because the variable is in the exponent. Okay, so step number 1 is to isolate the base and the exponent. So in this case, step 1 is already completed for us. The base is 3, okay, and the base and the exponent are on one side of the equation. Okay, step 2 is to take the log of both sides. So we end up with the log of 3 to the x plus 2 equals the log of 7. Okay, we know that the log of a base to an exponent is the same as the exponent multiplied by the log of the base, right? We can bring our exponent to the front. Okay, so we have x plus 2 times the log of 3 equals the log of 7. So we want to isolate our variable. So our next step is going to be divide both sides by the log of 3, which is just a constant. Okay, so now I have x plus 2 equals the log of 7 over the log of 3. And then my last step is going to be to subtract 2 from both sides. So x equals the log of 7 over the log of 3 minus 2. You don't want to use your calculator until the last step because you only want to round once. Okay, so in your calculator, you want to do the log of 7 divided by the log of 3 minus 2. And we find that x is approximately negative 0.2287656. Okay, and that is our answer. Okay, let's look at another one. Okay, so we have another equation. We have 8 times e to the 2x equals 20. Okay, so step 1 is to isolate the base and the exponent. Okay, the base in this problem is e, the exponent is 2x, meaning we need to move the 8 as our first step. Okay, so I'm going to divide both sides by 8. So I find that e to the 2x equals 2.5. Okay, step 2 is to take the log of both sides. And since our base is e, we want to take the natural log of both sides. So we'll take the natural log of e to the 2x equals the natural log of 2.5. The natural log and e cancel, leaving us with just 2x equals the natural log of 2.5. Divide by 2. Don't use your calculator until the very last step. So natural log of 2.5 divided by 2. You want to use your calculator, and then we find that x is approximately 0.458. Okay, so the next example similar, we're going to do the same steps. Okay, so we want to solve e to the 3 minus 2x equals 4, and in this case we're going to solve it with algebra, and we're going to solve by graphing. Okay, so first step is already done. My base is e, my exponent is 3 minus 2x equals 4. Okay, so step 1 is done. Step 2 is take the log of both sides. In this case, the base is e, so we'll use the natural log. Okay, natural log and e cancel, so I'm left with 3 minus 2x equals natural log of 4. Subtract 3 from both sides. And then divide by negative 2. And x is approximately 0.807. Okay, so that's algebraically. If we wanted to solve this by graphing, what you would want to do is on your calculator, you're going to graph each side of this. So your first function would be e to the 3 minus 2x, and your next function would be 4, and you would want to see where these two intersect. Okay, and when you do this, if you use the tracing function, you'll find that the first function looks like this. The second function is a constant function. And if you zoom in on the point where these cross, you find that the x value is pretty close to 0.8. Okay, let's look at another exponential function, but this time we need to factor first. Okay, so this is in a quadratic form. You notice the first term is e to the x squared, and then we have an e to the x term, and then we have a constant term. So when you see a function set up like this, you want to try to factor. Okay, so e to the 2x is e to the x times e to the x, because when you multiply, you would add your exponents. X plus x is 2x. Okay, and then 6 is probably 3 times 2. You want your coefficient to be -1, so that's a -3 and a +2. So now you have two equations. We want to use the zero product property. So if e to the x minus 3 multiplied by e to the x plus 2 is 0, then we know that either that is 0 or that is 0. Okay, so we want to set up our two equations. So we're going to solve each of these. So I would add 3 to both sides. E to the x equals 3. Okay, and then to get the variable out, I would take the natural log of both sides. So x equals the natural log of 3. Okay, and then when I look at the other side, I'd subtract 2 from both sides, so I'd find that e to the x equals -2. Take the natural log of both sides. Okay, we cannot take the natural log of a negative, so this particular function has no solution. Okay, so therefore x has to equal the natural log of 3, which is approximately 1.09. if you evaluate it on the calculator. Okay, and then we have one more to look at. The last example is solving this equation. So I have 3x e to the x plus x squared times e to the x equals 0. Okay, so we have a lot going on here. I'm going to start by factoring. Okay, I notice that they have an e to the x, they both have an x. So I'm going to factor out x e to the x, and for the first term I'm left with 3, and for the second term I'm left with x. Okay, so this is just factoring out the greatest common factor. Okay, so there's actually 3 parts to this. Okay, if we think about the zero product property, this could equal 0, e to the x could equal 0, or 3 plus x could equal 0. Okay, so we want to look at all 3 parts. Okay, so we already have one solution. X could be 0. E to the x never equals 0, so this part will not give us a solution. And the last part is 3 plus x equals 0, so if we just subtract, we find out that x is negative 3. So our 2 solutions are 0 and negative 3.